Assalamualaikum and hi. I'm Hanif Henry with the student ID 220126162, and today I will be explaining the code, the void setup, and the void loop for this project. First of all, we need to know the library that we include in this project. First of all, we include the liquid crystal I2C.h. We need to include it because we connect the LCD to the Arduino via the I2C with the port SDA and the SCL. Without the I2C, we need to connect many pins from the LCD to the Arduino. Thus, with this library, we could reduce the port used in the Arduino. And next, we need to declare the time credit as a integer, the global variable for the time credit system. And we go into the void setup. First of all, we need to declare all of the input pin and the output pin for the pin that will be used in the Arduino. For example, pin analog 0 for temperature sensor, analog 1 for humidity sensor, and analog 2 for the pH sensor. The three pin is used for the input 1. And we go to the pin 12 as a buzzer, pin number 2 for the fan relay, pin number 3 heater relay, pin number 4 water mister relay, pin number 5 acid pump relay, and pin number 6 base pump relay. The 6 pin that mentioned earlier will be used as output pin. And we start with the serial begin 9600, and we show to the user that we are initializing as together with the LCD displaying the same word also. And after the LCD and the serial port has done explaining showing the initializing, we have some ringtones sound by the buzzer to give a good user experience to the user. All of the code that done by the void setup will be done only once. We going to the other function as void temperature control. We go to the void humidity control and the loss one void pH control. This is the function that will be called into the void loop later. And we go to the void loop. First of all the code inserted under the void loop will be done in a continuous loop until it says to be break. But in this project, in this situation, the code will be looped for infinite times. And as initialization, we start with our time credit equal to 15. We take a simple analogy. A one time credit equal to 1 minute. And we go to the serial print. We inform the time credit is this is for the debugging purpose. And we go to the time credit. Okay, next we need to done the three control. First, we need to done the temperature control. After that, we done the humidity control, and next we done for the pH control. All of the functions will be called at the function that we had written before, at the line before the void loop, and will be explained later. And then after we go to the third, after the three control, we will inform the time credit. For your information, the time credit is actually a time that use for each control takes. Temperature control can takes from 0 to 5 time credit. That means from 0 minute to 5 minute. Same also with humidity control and pH control. The balance of the time credit that did not use by of the three function will be included into the next time log. That means every uh every temperature control, every humidity control, and every pH control will be done exactly, precisely every 15 minutes, thus ensuring the consistency frequency. Because of that, we introduce the time credit system. After the time credit have reached its balance, it will be idle for the balance of the time credit and will be shown in the serial print and the LCD print next time blocks in time credit minutes. For example, like 5 minutes, 10 minutes, and it can be 0 minute also. After it finish the time credit, the process go back to the initial, will go back to the time credit equal to 50, and the process will be kept in the loop. So all of the temperature control, humidity control, and pH control will be done precisely every 15 minutes. Thank you and have a nice day.
Hello, my name is Imran Harirul Bilokman, and today I will guide you on my programming part, which is temperature control. So in our system, the temperature is monitored up to 5 times, with each check representing 1 minute. The sensor measures the temperature, and the system converts it into a readable value using the TMP36 formula, which we can see right here. After each reading, the system checks if the temperature is within a safe range. If it is too high, it is greater than 36 degrees Celsius, as presented in this code. The buzzer sounds for 5 seconds to alert us, and the fan runs for 55 seconds. And if it is too low, which is less than 18 degrees Celsius, the buzzer also sounds for 5 seconds, but this time the heater turned on for 55 seconds to warm the environment, which the code is right here. But if it is normal, uh, it it will continue to the next block. So later on, I will show you the both three cases of simulation. Okay, so in first scenario, where the temperature is greater than 36 degrees Celsius, I will show you through a simulation. You can see from here, the fan will be turned on for 55 seconds and the buzzer was turned on for 5 seconds. Now, let's see the scenario where the temperature is less than 18 degrees Celsius. As you can see here, the heater is turned on for 55 seconds and the buzzer was turned on for 5 seconds. Lastly, we will see when the temperature is normal. As you can see, when the temperature is normal, it will continue to the next control, which is a humidity control.
Assalamualaikum and hi, I am Muhammad Syakir Afnan bin Suhaimi. I will explain the part of the coding that I work on, which is humidity control function. The function is called humidity control. The purpose is to read the humidity level, display it, and take action if humidity is low. First, the code will show the message humidity control on the serial monitor and the LCD screen. Next, the code runs a loop to read a humidity sensor that will cycle for 5 times. The code read humidity using analog read A1. The pin is at A1. This is raw value, so I convert it into real humidity percentage with a formula that I make. This is the formula. Then, after reading the value, the system will check if the humidity is more than 14% or below it. First is, if the humidity is below 14%, the buzzer will be sound for 5 seconds and the water meter will turn on for 5 seconds. Here is the coding for buzzer and here is the coding for water meter. If else, that means the humidity is more than 40%, it indicate that the humidity in the greenhouse is normal. The LCD will display humidity normal. Next, let's start our simulation to see how the condition is working. Humidity control reading data. So here the humidity is 29.7%. That means the humidity too low. So the buzzer will be sound for 5 seconds and the water meter also will be turned on for 55 seconds. Now we look if the humidity high, there is more than 14%. As we can see, the humidity is high, 70%, more than 70%. That means the humidity is normal. So, the code will be moved to the next control, that is pH control. That's all from me.
I am Fakrul Razi, and my role in this project was to build the pH level control system, which is used to ensure the chemical environment in the aquarium remains stable for the fish. So once the system is done calling the temperature and humidity control functions, it will then move on to the pH level control system. The system will read the data from analog pin A2, which is connected to the first potentiometer here, which will be acting as a pH level sensor alternative, since there is no pH sensor in Tinkercad. And after reading the data, it will print out the pH level on the LCD. If the pH level is lower than 5.5, then the water is too acidic. Thus, it will trigger the buzzer for 5 seconds. After that, the DC motor is activated for 55 seconds, which is an alternative to alkaline pump output, since that component is not available in Tinkercad. In real life, suitable alkaline solution will be pumped into the aquarium in order to neutralize the water. If the pH is higher than 8.5, then the water is too alkali. Thus, it will then trigger the buzzer for 5 seconds and then the DC motor is activated for 55 seconds. And this time will be an alternative to acid pump output, since that is not available in Tinkercad. The acid pump should pump out parasitic acid into the water, which is harmless to fish and actually provides benefits to the water by being highly effective against fish pathogens and bacteria at low concentrations. Parasitic acid also degrades spontaneously to harmless residues in order to not cause any harm to the aquatic life in the aquarium. Then the system will read the pH level again to see if the water has been neutralized. If it is not, then it will repeat this for loop again until it is neutralized to the optimal ranges of 5.5 to 8.5. In the worst case scenario that it doesn't neutralize, the loop will automatically break once it reaches its fifth repetition in order to complete the 15-minute time block. For the idle time, which is the time that the system rests, the idle time should be equal to the balance of the remaining time credit left. So, once all the sensors have finished their function and loops, the time that is left in the time credit will be the time that the system rests. In the coding, it is written as this line here. So, it will delay for how many time credit left, and the calculation is time credit times 60 times 1000 in order to convert minute to milliseconds. Once the idle time is over, void loop will repeat, thus starting a new loop. This will go on until the aquaponic system is closed.